All right, I'm going to show you how to use the Vernier app that I just had you guys download. So this is Vernier Graphical Analysis. These are the instructions that I gave you in the introduction. First things first, you want to open Vernier Graphical Analysis. So go into your bottom and you can type in Vernier or Graphical Analysis, whatever you want to type. I'm just going to do Graphical Analysis. And when it's open, we're going to be doing a new experiment rather than a old one. And so this is the app we're going to use constantly in physics. When it opens, this is going to be the home menu. You have 3 ways to make a new experiment, and you can always open an old saved file if you have one. The first way to do this is to do sensor data collection, which means you actually plug a sensor into your Chromebook. So when you're in the class, you'll be able to do this. Data sharing is if you aren't the person using the sensor, maybe the teacher is doing a demo, or maybe one of your group members are doing it. You can share the data over Wi-Fi. So you have to be pretty close and in the same vicinity to do this. Or you could always type in manual entry. So today we're going to show you how to do a manual entry. So go ahead and click on manual entry. We're going to start by naming our file just in case your Chromebook dies or the app crashes. So we're going to go in here to the untitled and go to save as. What's going to happen by default is this might be in the wrong folder. So you want to go to the 3 things and make sure you go to your personal drive. It should be your apps if you have multiple connected. And then you can choose in there where you want to do. I'm going to my drive specifically, and then I have one for Vernier Labs, but you might just want to put it in your physics folder. And we're going to name it maybe a sample. And we go save. Right, so now it should say sample in the corner. And what we can do from there is we can start our experiment. So we have the data table over here we want to do, length and time. This might be for some experiment you're not used to. And so we want to make this data table in the data table. So first off, number 5 says to rename the X and Y columns to match our data table. So we're going to start with length. Either you can tap on the X here, or you can tap on these dots here. We're going to go into column options, and you're going to rename it length. And if you've been in science for a while, you know that everything has measurement units. And so the units over here are super important. They're actually what's in parentheses in the instructions. So we're going to measure in meters. It's very different than inches or centimeters, and it's important. Time is the other one. And so we're going to go for time in seconds. Now, for regular physics, you can ignore everything else down here, but if you're in IB physics, you may want to consider using significant figures or scientific notation. You also might want to set specific significant figures in decimal places if that is part of your experiment. Now that you have the data table set up, we need to actually put the data in. So you can either type and do it by hand, like I just did, and the dot will show up on the graph. It'll auto zoom in. You can fix that if you don't like it. Or what's cool on the Chromebook is you can actually copy and paste. And so you can go ahead and paste. It actually takes a second, so let it load. But you can do 1 column at a time. Do not try and do both, or it will not work. And so sometimes you have to press it twice, but there's all 5 data points. That's the benefit of working with groups, is if you have a data table, you can copy and paste. So this is a beautiful graph. You can see it has the name, it has the type, it has the dots, has an axis. Down here is graph tool options. And so there's a lot of things you can do. If you wanted to give it a title, for example, we could call this length versus time. We could go ahead and make sure that we have the right scales. Say you wanted to start at 0, you definitely can, just to kind of see how that changes things. You can start at 0, which is actually pretty normal for a lot of things. We start at 0. That also kind of helps us see that there's something a little bit strange happening. It's not quite what we thought maybe at first. It might not be a line. And so step 7 in your instructions says to put a curve in. So we click on that graph button again, and we can apply a curve fit. So this is fitting a line through the data. It's going to default to a line, which will run somewhere into the y-axis. And so you can kind of tell looking at the data points that the data are not falling on it. Sometimes that happens in science, but you want to check the other fits to see if there's a better one, like quadratic or maybe power. So if this were truly supposed to go through the 0, power was better than quadratic. Another way of checking if it's a good fit is to look at the RMSE, or the root mean square value. And so if this is close to 0, you're doing pretty well. So you can get rid of the things by Xing out, but for this thing, I want you to choose the best curve fit, do a screenshot of your example, and paste it under the proof column and turn in your assignment. Hopefully that helps you to get this done. There are many other things you can do with this, but that was all for today.